Hi everyone, I'm here with your 1, 2, 3 lesson. What can a rectangular array show? Characteristics of numbers. In lesson 121, you worked with your team to find different ways of showing different numbers of pennies. One arrangement that can be used to represent any whole number is a rectangular array. An example is shown at right. The horizontal lines of pennies are called rows, while the vertical lines of pennies are called columns. In this lesson, you will use rectangular arrays to investigate the properties of numbers. Use the following questions to help focus your team's discussion today. Can all numbers be represented the same way? What can we learn about a number from its representations? 162. How many pennies? Part 1. Jenny, Ann, and Gigi have different numbers of pennies. Each girl has between 10 and 40 pennies. Work with your team to figure out all the possible numbers of pennies that each girl could have. Use the clues given below. Be ready to explain your thinking to the class. A. Jenny can arrange all of her pennies into a rectangular array that looks like a square. Looking like a square means it has the same number of rows and columns. So any number between 10 and 40. Try to figure out how many pennies Jenny could have. Okay, so a perfect square means that we have the same numbers of rows and columns. So Jenny could have 16, 25, or 36. This would be a 4 by 4. This would be a 5 by 5. This would be a 6 by 6. B. Anne can arrange all of her pennies into 5 different rectangular arrays. So try and figure out how many pennies Anne could have. Okay, she could have 36. That would mean it's 1 by 36, 2 by 18, 3 by 12, 4 by 9, or 6 by 6. Whenever Gigi arranges her pennies into a rectangular array with more than one row or column, she has a remainder. In this case, this is going to be leftover pennies. So which ones would give her a remainder? So 11, 13, 17, 19, 23, 29, 31, or 37. All of those would give her a remainder. And if you weren't sure, you should be sketching those out, okay? That's a great tool. I should be able to see your thought process and see your work. 163. What can you learn about a number from its rectangular arrays? Consider this question as you complete parts A and B below. A number that can be arranged into more than one rectangular array, such as Ann's in part B of problem 162, is called a composite number. List all composite numbers less than 15. So can be arranged into more than one rectangular array. If you need to sketch them out, sketch them out. We should have come up with 4, 6, 8, 9, 10, 12, and 14. B says, consider the number 17, which could be Gigi's number. 17 pennies can be arranged into only one rectangular array, 1 penny by 17 pennies. Any number like 17 that can form only one rectangular array is called a prime number. Work with your team to find all prime numbers less than 25. So they can just be arranged in one array. Hopefully you came up with the following list: 2, 3, 5, 7, 11, 13, 17, 19, and 23. Moving on to 164. Jenny, Ann, and Gigi were thinking about odd and even numbers. When even numbers are divided by 2, there is no remainder. When odd numbers are divided by 2, there is a remainder of 1, Jenny said. Odd numbers cannot be formed into a rectangle with 2 rows. Does that mean they are prime? Consider Jenny's question with your team. Are all odd numbers prime? If so, explain how you know. If not, find a counterexample. A counterexample is an example that can be used to show a statement is false. In this case, finding a number that is odd but not prime. So go ahead and work on 164. Okay, if you're back with me, you came up with your answer for 164. So no, not all odd numbers are prime. Then you should have come up with a counterexample, which again is an example that can be used to show that that statement is false. So we're trying to show that the statement that odd numbers are prime is false. So composite odd numbers and if you go back to problem 163, you have some counterexamples. 9, 15, and 21 are all composite odd numbers. Okay, finally, question 165. How many pennies, part 2? Work with your team to figure out how many pennies between 10 and 40 each person could have. Use the clues given below. You may want to use diagrams or expressions to help you determine your answer. When Alexander arranges his pennies into a rectangle with more than one row, he always has some leftover pennies. When he uses 2 equal rows or 3 equal rows, he has 1 leftover penny. When he arranges them into a rectangle with 4 equal rows, he has 3 leftover pennies. Go ahead and try and figure out part A. Okay, when you're done with that, we're going to move over to part B. When Jorge arranges his pennies into a rectangle with 2 equal rows, 3 equal rows, or 5 equal rows, he has 1 leftover penny. When he arranges his pennies into a rectangle with 4 equal rows, he has 3 leftover pennies. How many pennies could Jorge have? So again, work on part B. And part C, when Louisa arranges her pennies into a rectangle with 2 equal rows, 3 equal rows, 4 equal rows, or 6 equal rows, she has 1 leftover penny. When she arranges her pennies into a rectangle with 5 equal rows, she has 2 leftover pennies. How many pennies could Louisa have? Go ahead and figure out part C. Okay. There are different solutions for this, so as long as you support your answers and explain your reasoning, you will be okay. If you would like me to look at this, I'll be more than happy to do that, but that is it for this lesson.